A doubly linked list is a type of linked list in which each node contains a data element and two pointers, one pointing to the next node in the sequence and another pointing to the previous node. Here is an example implementation of doubly linked list in C language. These are standard header files. stdio.h is included for input and output operations, and stdlib.h is included for dynamic memory allocation using malloc and the exit function. Now let's define the node structure. Here int data is a member that represents the actual data stored in the node. It could be of any data type, but in this case it's an integer. This member is a pointer to the next node in the linked list. Since it's a doubly linked list, each node has a reference to both its next and previous nodes. This pointer points to the next node in the sequence. This member is a pointer to the previous node in the linked list. Again, in a doubly linked list, each node has a reference to both its next and previous nodes. This pointer points to the previous node in the sequence. So a node in this implementation contains an integer data element and two pointers, one pointing to the node in the next sequence and the other pointing to the previous node in the sequence. This structure is commonly used in doubly linked list implementations, where each node maintains a connection to both preceding and succeeding nodes. Now we will create a node function. Here, this is the function signature. It returns a pointer to a struct node, and it takes an integer parameter data which represents the data to be stored in a newly created node. This line uses malloc function to allocate memory for a new node. The size of struct node is used to determine the size of the struct node in bytes. The result is cast to struct node asterisk to indicate that the memory allocated for a struct node. If the allocation fails, it returns a null pointer. This part of the code checks whether the memory allocation was successful. If new node is null, it means that the memory allocation failed. In such cases, an error message is printed and the program exits with the failure status. This line assigns the provided data to the data member of the newly created node. This line initializes the next pointer of the new node to null. Since this is a new node, it's not connected to any other nodes yet. Similarly, this line initializes the previous pointer of the new node to null. Finally, the function returns the pointer to the newly created and initialized node. In summary, this function dynamically allocates memory for a new node, initializes its data, sets both next and previous pointers to null, and returns a pointer to the newly created node. It includes error handling to check for the successful memory allocation. Now we will insert at the beginning. This is the function signature. It takes a pointer to a struct node, that is head, and an integer data as parameters. The function is designed to insert a new node with the given data at the beginning of the doubly linked list. This line creates a new node using the createNode function, which we discussed in previous breakdown. It allocates memory for a new node, initializes its data with the provided value, and returns a pointer to the new node. This part of the code checks if the linked list is currently empty. If the head pointer is null, it means there are no nodes in the list. In this case, head pointer is updated to point to newly created node. If the linked list is not empty, this part of code is executed. It first sets next pointer to a new node to point to the current first node in the list, that is head. Then it sets the previous pointer to the current first node to point to the new node. Finally, it updates the head pointer to point to the new node, making it the new first node in the list. In summary, this function inserts a new node with the given data at the beginning of the doubly linked list. If the list is empty, it simply updates the head pointer to point to the new node. If the list is not empty, it adjusts the pointer of the existing first node and the new node to maintain the doubly linked list structure, and then updates the head pointer to the new node. Now we will perform insert at the end function. This is the function signature. It takes a pointer to a struct node, that is head, and an integer data as parameters. The purpose of this function is to insert a new node with the given data at the end of the doubly linked list. This line creates a new node using createNode function. Similar to the insert at beginning function, it allocates memory for a new node, initializes its data with the provided value, and returns a pointer to the new node. This part of the code checks if the linked list is currently empty. If the head pointer is null, it means there are no nodes in the list. In this case, the head pointer is updated to point to newly created node. If the linked list is not empty, this part of the code is executed. It starts by creating a temporary pointer temp and initializing it with the current head of the list. This loop traverses the list until it reaches the last node. This is done to find the current last node in the list. Once the last node is found, the next pointer of the last node temp is greater than or equal to next is set to point to newly created node, effectively adding the new node at the end of the list. The previous pointer of the newly created node is set to point back to the last node, that is temp, establishing the backward link in the doubly linked list. In summary, this function inserts a new node with the given data at the end of the doubly linked list. If the list is empty, it simply updates the head pointer to point to the new node. If the list is not empty, it traverses the list to find the last node, adjusts the pointers to maintain the doubly linked list structure, and then inserts the new node at the end of the list. Now we will see the print list function. This is the function signature. It takes a pointer to a struct node, that is head, as a parameter. The purpose of this function is to print the elements of the doubly linked list, moving from the beginning to the end. This loop iterates through the linked list, printing the data of each node. The loop continues as long as head is not full, meaning there are more nodes to process. Inside the loop, it prints the data of the current node using printf. The format string %d is used to print an integer followed by the string. This format is common for displaying elements in a linked list. After printing the data, it moves the next node by updating the head pointer to point to the next node in the list. After the loop completes, it prints null to indicate the end of the linked list. This is done outside the loop to avoid the printing separator after the last element. In summary, this function traverses a doubly linked list starting from the given head pointer and prints the data of each node in the format data. The loop continues until it reaches the end of the list, that is, head becomes null. Now we will see the main function. This line declares a pointer to a struct node named head and initializes it to null. This will be the starting point of the doubly linked list. This line inserts a node with the data value 10 at the beginning of the doubly linked list. The address of the head pointer is passed to the insert at beginning function so that it can modify the head pointer if necessary. This line inserts a node with the data value 20 at the end of the doubly linked list. The address of the head pointer is passed to the insert end function to update the list. This line inserts a node with the data value 5 at the beginning of the doubly linked list. Again, the address of the head pointer is passed to the insert at beginning function. This line prints a message indicating that the following output will be the representation of the doubly linked list. This line calls the print list function to print the elements of the doubly linked list, starting from the head pointer. This line indicates that the program executed successfully and 0 is returned to the operating system. In summary, this main function creates a doubly linked list, inserts nodes with the data values 10, 20, and 5 at the beginning and the end of the list, and then prints the entire doubly linked list. The output would be something like this.
Like, comment, and subscribe.